So what is the for statement really doing in that case? It's stepping through a predetermined list of variables, right? But you can make a list of variables yourself beforehand. You don't have to do it that way. You don't have to set it up like this. Say we wanted it to count the numbers 1, 3, 5, and 8 for whatever reason. I could say, and by the way, I use a capital L when I'm using this list variable just because that looks like a 1, right? And lowercase l looks like a 1. So I could do this. This list, L is equal to square brace 1, 3, 5, 8. And then when I do a for statement to iterate through that, it'll print out 1, 3, 5, 8. So the thing here in this for syntax doesn't just have to be a range word. It could also be a list, or it could even be a string. Like if I did this, name equals quote Fred end quote, and then I did for x space in space name colon print x. It's going to print out every character in that string, right? F-R-E-D. So it iterated through this just like it was a list, which in a way it is. It's a list of characters. So if you're not going up by ones, you can specify the value that you want to go up by. If you want to skip by twos, you put a comma 2 at the end of it. If you want to skip by threes, you put a comma 3 at the end of it. In that case, you would need to specify the starting value so that it would know where to start, where to end, and then how much to go up by each turn. So if we said 1, 6, 3, it would start off at 1, then it would add 3 to it, which makes it 4, and then it would add 3 to it again, which makes it 7, which is way past the limit, so it would stop. So we're on Lecture G.
Why is it 1, 1, 1?
It isn't. You didn't see that.
Not good, isn't it?
So if we do this, for space x space in space range 10, that's going to count from 1 to 9. Excuse me, it's going to count from 0 to 9. If I say for space x space in, for x in range 10 in parentheses colon, but I specify it starting at 2, like that, it's going to count 2 through 9. If I do for x in range 2, 10, 2, it's going to go 2, 4, 6, 8. I forgot the colon, so that would be a syntax error. So these are all examples of definite loops. We know in advance, the computer knows in advance how many times it's going to iterate. If it's not a definite loop, you'll probably write it as a while loop. An indefinite loop is one where the computer doesn't know in advance how many times it's going to iterate. So for example, if you were going to roll 2 dice and you wanted to stop rolling whenever you got 2 6s, you could do that, but we would need a random number generator. Random number generator just means something that picks a number that we can't predict in advance, just like rolling dice. Let me check something. Yeah, okay. So, in order for our random number generator to work, I need to import the random library. So after all my for loops, I'm going to do import random. And I'm going to call my dice D1 and D2. So D1 equals random dot randint, randint. No spaces, randint. And the dies got 1 through 6, so 1 comma 6. Now that took a lot of typing, so I'm just going to copy that and paste it and change it to D2. So why don't we print out D1 and D2 and then have a while loop that keeps checking to see if we roll a 12, if we got 2 6s. So print parentheses D1 comma D2. I'm going to stop there and make sure I don't have a syntax error before I add a while loop. Okay. Because so far all we've been doing is printing numbers and the output's not going to leap out, let's add a description to what we're printing here. Like print parentheses quote I rolled end quote comma. Like that. All right, how do we check to see if we roll 2 6s? Well, there's one syntax where you use what's known as the AND keyword, but on the other hand, we could just add them up and see if they equal 12. So while D1 plus D2, and when I say not equal, I type that with an exclamation point. Exclamation point equal 12 colon. And then just take those 3 statements, not the import, but the D1, the D2, and the print, copy and paste them and indent them under the while loop. Please don't type all that in a second time when it's as easy as selecting them, copying them, pasting them, and then tabbing them over.
But indent them first.
Yep, gotta indent them there. All right.
Because Python's rather picky about that.
Yep. All right, so now it's going to keep going until D1 plus D2 equals 12. This is an indeterminate loop because the computer has no idea if we're going to roll a 12 on the first roll or on the 100th roll. And each time I roll, I should get different results. Right, 6, 5, 6, 1, whatever, right? Took a while. I am curious about how many times it actually took. We could add a counter. I'm not going to bother this time, but it's, see, that time it only took 7 or 8 rolls to get the pair of 6s.
I got a lot.
And sometimes it takes quite a bunch. So a definite loop steps through this as a fixed predictable number, a predefined number of times. That's good enough. Let's go with that. So a definite loop steps through a predefined set of values. Indefinite loop iterates until a condition becomes false.
Can that be the case in C++ or any other languages except Python?
Yep. Pretty much all languages, well, I won't say all languages, but C++ and Java definitely have a way of doing both of these things. But the syntax in those is just a little bit different. You don't use a range statement, and I know you know this, but you do something like this. And by the way, guys, the rest of y'all don't have to type this, right? Totally different language. This is not Python. It's not a range statement, so it looks a little bit different, but this means starting at 0 and keep going while I is less than 10, adding 1 to I each time. I think I'll make it like that so that's so this is not Python. This is C++ and Java. Don't bother typing it unless you've taken those languages and you care.
Well, thank goodness I asked that one. Those are some scrappy CIT students, quote unquote.
Yeah. So a loop that counts down, you just put a negative value in the last spot. So if you say 10, 0, -1, it goes 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and it stops before it hits that 0. So if we wanted to go 10, 8, 6, 4, 2, we could do that. If I could click on the right window, let's try this again. For X in range, I want it to start at 10, and I want it to go 10, 8, 6, 4, 2, so I'm going to put some number less than 2, but more than 0 here. So 10, comma, keep going, and stop before you hit 0, and go by -2 each time. And so what's that going to do? That's going to print 10, 8, 6, 4, and 2. I hope you're seeing the pattern. I hope it's becoming real obvious now. Start point, end point. The start point is inclusive, so it definitely begins with it. The end point is exclusive, so it stops whenever it hits it. So that's why we didn't print out a 0 there. And then the -2 is the step, either step upward or step downward.
Can you put -2 as that?
Where at? Like here?
Mm-hmm.
Yeah, it would go down to 0, right? 10, 8, 6, 4, 2, 0, and then it would stop before it hits -2. I'm going to change it back since my comment says 0, but yes, you could. I mean, you could start from -200 and go to -400 if you wanted to. So formatting text for output. There are two ways of of formatting Java print statements. This is going to show one, where you do something that looks like this, where you use these % signs as placeholders. Now, of course, they made it really, really complicated for your very first introduction to it. Way to go, guys. Instead, we're going to start simple and make it go more complex. So I want to count the numbers, let's say from point 10 up to point 90, right? Like fractions, like decimal points. Here's what I wish I could do. I can't, so don't type it. I wish I could say start at point 10 and keep going, up until you reach, 1.00. Unfortunately, the range statement doesn't deal in fractions. It doesn't deal in floats. It only deals in whole numbers, which is one reason why the C++ statement I showed up here is nicer, because you could make this fractional values, right? But we're not going to complain too much about that, because the rest of this language is so cool. So I'm going to start off at 1, but then when I print my output, I need to divide it by 10 to get my 0.1. You know what, that's getting almost too complicated, but yeah, let's run with it. Okay, so go from 1 to 10. Notice I left off the third number. If you leave off the third number, it just goes up by 1 each time, which is enough. But I wanted to print out 0.1, 0.2, 0.3, etc. So I need to divide our x by 10 so that we get 0.1, 0.2, 0.3, etc. Y is equal to x divided by 10. And now I'm going to print out
y.
Yeah. Or let's print out you know what, we're going to make this more interesting than that. Print out 1 divided by x. So to print out 1 over 1, 1 over 2, 1 over 3, 1 over 4. And so then print out y comma x. And let's take a look real quick at what its output is and why we don't like it much. Right? It's real jagged. Doesn't look too cool. We want to line these numbers up so that they're easy to spot, right? Kind of like an Excel spreadsheet or hitting tab in a Word document to make everything look good. Well, we need to use what's known as a formatted print statement to get that to work. Rather than modify that one, I'm just going to rewrite it completely. Print, parentheses, quote, %, D, which means a decimal number, space, %, F, which means a floating point number. And maybe we'll stick a tab between them. No, that'll make it look too complex. So end quote, %, and I'm going to have an opening quote and 2 close quotes. And inside this pair of quotes here, I need to fill in that placeholder and that placeholder. So I'm going to put in y and x. And by the way, I botched it. What do I mean by that? Which one of these is really the floating point value? The first one or the second one? When I ran it, all the decimal points were first. So this is the floating point value. So when I said %D, %F, these should have been swapped. %F, %D. Now the output for this isn't going to be any different than what it was before, or not much, most likely. But we're 2/3 of the way there towards making it look good. Well, what do you know? It already looks great. There's hardly anything we need to do to change that, right? So the formatted print cleaned things up. But what if I only wanted 3 decimal places rather than 6? What if I thought that was excessive? Well, what I'm going to do is between the % and the F, I'm going to say %.3. The dot means that after the decimal point, I want 3 places of precision. I want 3 numbers after the decimal place. And now it's starting to look really good, right? Maybe we want more space between the 1 and the 9, right? You know, we could like put a /t, a tab character. We could do something else. This is so much fun. Why don't we not stop at 9? Let's go all the way up to 20. So if I want to go to 20, what am I actually going to have to put here?
21.
Yep. So let's put 21 there.
Well, yeah, what's 9 plus 10?
Now it's going to look go for a lot longer, but there we go. That's good enough in my opinion. But I still want to illustrate one more thing, which is that you can specify how wide you want these. What do I mean by that? What if I wanted this to occupy 10 columns of space, and I wanted the next one to occupy 5 columns of space? I'll probably undo this, so you don't necessarily have to type it, but that's 10 columns of space, and that's 5 columns of space. So the syntax is the number sign, the number after the % indicates how many spaces it's going to fill. If there's a dot, it's specifying the format for the fractional component. And last but not least, if you want a number to be left justified rather than right, like if you want the extra spaces to be on the right side rather than the left, you can do that as well. I'm going to leave that alone for now. I think that's good. Actually, I'm going to take out these parts because they make it a little bit hard to read, right? I mean, for our very first entry. So you can use that, in a lot of different applications. Like if you're going to print dollars, you'll usually do .2f so that you can get dollars and cents. So like if the price of our item is $10 plus 10 times the tax rate, which I think in Oklahoma, in Midwest City is like 9.25. I could be wrong about that. And then we want to print the price out. Print parentheses, quote, price is, end quote, comma, price, but that's not going to be good enough because that'll display maybe more than 2 decimal places. It might not in this case. It only displayed 1. We don't like that, right? We like to see 50 cents, not 0.5. So I'm going to modify this. %.2f. But then remember up here we had to have a % sign rather than a comma. You had to have a % sign, and then the thing that you were formatting needed to be inside its own parentheses. So the syntax is a little bit arcane. So the guys who invented Python 3 came up with a slightly different one. And it's different enough that I always have to Google it. But that'll format it for dollars and cents. I could even stick a $sign in front of it, like that if I wanted to. And there we go, right? Now that's looking like a proper price. So to print dollars and cents, how about I spell it with a C? Pretend I know how to spell it. We usually use % or $sign %.2f. And what does the F mean? F means floating point. F is for float, while D is for decimal, is for int. So D equals int. And if you need a string, S is for string. I'm going to print out the price using a different, and I did not mean, yeah. So here's a different way of doing it. Print, parentheses, quote, price is $, curly brace, 0. I'm not liking doing the 0, and you can actually leave it off, so I'm going to leave it off. And my short-term memory failed, so I'm going to go take another peek. So then you use the colon to specify that it's floating point. And then you put the close curly brace there. And then you do an end quote, dot, format, parentheses, price, in parentheses, in parentheses. Now that doesn't specify to 2 decimal places. I don't see that as being a lot better than the one up here. I'm not seeing a compelling argument for doing it this way. I know that one capacity that this is better than the other one. And I'll show it to you on that web page, but I'm not going to type it in as an example. All right, so again, it's showing 6 decimal places. That's not too cool. Let's hit the web page again and see how to format it exactly to the right floating point. Yeah, you just specify again the dot followed by a number. So here I could do .2f, and it'll format it out to dollars and cents. Personal choice. If y'all want to use dot format and you're Googling code and you're, the answer that you're Googling. By the way, never Google an entire program and copy and paste. I know I ranted about that, for 15 minutes. But you're certainly allowed to go and find syntax, right? How to do a particular step or two, and then take that from Google, put it in your code, modify it to meet your exact needs, make it your own, make sure you understand it. So these two things provide identical output You can tell that they look a little bit different, but they also have some commonalities, right? They both use .2f to specify the number of decimal places. Good enough, I think. I think that's enough to show that this is an alternate format. Conveniently, it actually has the word .format in it to remind us that it's the alternate format. I don't care which one you use. I'm going to stick in this class to using this one because that's what the book shows, and that's what I'm most familiar with anyways. Like I said, it's used in a lot of different languages. So when you're formatting text, the book shows it in a pretty complex format, right? But if we break it apart, we can figure out what it's doing. I told you that to left justify, you can put a minus sign in front of it. In this particular case, there's no need to right justify it. In this particular case, they didn't put this in a monofont font, so you can't even see what it's doing. But I could fix that real fast. Try to put it in Courier. All right, that's looking a little bit better. All right, so the minus sign means stick it up against the left margin. If you leave off the minus sign, it doesn't go against the left margin, so these would actually probably go against the right margin. Man, they mess these up. There we go. I think that's pretty close to what they wanted us to do. If we look at it, what does that 3 mean? It means fill it out to 3 spaces total. So we have 1, 2, 3 spaces there, up to the point where we have 3 spaces there. And when we have %12D, that means format this out to 12 spaces. Well, let's see if this is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not quite, so we would need an extra space in all of these. Man, I wish that they hadn't made me do all those corrections. And there we go. So that's what this means. %3D makes this give 3 spaces. %12D gives this one gives this one 12 spaces. The minus sign means justify this on the left margin. The absence of a minus sign means justify it on the right margin. That's kind of neat. I'm almost tempted to print that as an example. Yeah, I don't know. Nah. Yeah, I better do it just because of the hyphen, right? But we'll do it slightly easier. Let's just count from 1 to 10, take the exponent of it so that we have lots of zeros to play with. So 4x in range, parentheses, 1 comma 11, so that I can get 1 to 10, colon, print, parentheses, quote, % minus, and I don't know how many spaces we're going to need to fill that up. I think we're going to need 12. % minus 12D. In other words, occupy 12 spaces on the screen and format it as an integer with no decimal point. That's what D means. End quote, %sign, 10 * x. And so you may remember that if you take 10 to the power of something, it kind of indicates just how many zeros it is, right? 10 to the power of 1 has 1 0, 10 to the power of 2 has 2 zeros, and so on. And then take that statement, copy it, paste it, but remove the hyphen. So just take those double pair there, remove the hyphen. There, you see the difference. The hyphen justified it against the left margin. Leaving it off justified it against the right margin. Looks like I didn't quite get enough spaces here, or I had 1 too many. Yeah, 1 too many. So I'm going to modify these to 10. 1 comma 10. No, that's not right. That's not what I'm supposed to modify, right? Because then it would only count 1 to 9. Instead of 12D, I'm going to make them 11D. That way the two examples will line up, because they're only filling out 10 spaces. Or 11 spaces. Because that's what I says. All right, there's a slight difference between this format and this one. Don't do this, but I'm going to copy this one and paste it under here. And I want you to tell me if you spot a difference in the syntax between this one and this one. And what do I mean difference in syntax? Like maybe there's an extra symbol or a couple of extra symbols in this one. Anybody spotting it? Specifically, this variable as opposed to this variable. What is this variable enclosed in that this one is not? All right, guys, somebody got to tell me. What is surrounding this variable that is, this variable has symbols around it, this one doesn't. So what's the difference?
Parentheses.
Yeah, this one's got parentheses. The parentheses are optional if you're only printing out one variable. If you're printing out two variables, the parentheses are not optional. So really, I should get you in the habit of always doing that, but it looks so much cleaner if you can leave it off. And you can leave it off if you're doing only one variable being printed out. But just to make it, the most robust thing possible, so that if I was going to print out two variables, I wouldn't have to suddenly go back and add the parentheses. I'm going to modify it like that. Maybe I will add that as a comment, though. You can leave out the inner parentheses if printing only one variable, one placeholder. Alright, so what I'm going to do next is I'm going to Google up a formula. It's of vague interest to us. What if you have an interest-earning account? Once upon a time, even checking accounts had earn interest. Nowadays, interest rates are so low, it's set by the Fed, that checking accounts absolutely do not earn. But if we do interest formula, we'll see this formula. This part here is problematic. Why? Because you'd have to put an asterisk between the n and the t. You can't just put nt and have it magically multiply those two variables together. So you'd have to put n asterisk t. And if you were going to do that, well, I'm going to start turning this into an equation, but it's going to take several steps. And I'm going to put it in as a comment, but let's see if I can come here. If I was going to do that, I'm going to take one shot at it first, and it's going to be wrong. So if you feel like waiting until the end, what's the exponent symbol? Star, star. Okay, now that's wrong, right? So I just said that if you have two variables shown in a formula that you Google up, and they're right next to each other, you got to put an asterisk there. Now that looks a lot more correct, but it's technically not. These have to be in parentheses, exactly, because n and t have to be multiplied first before you can take them up to an exponent. Otherwise, what's it's going to do? It's going to do all this, it's going to raise that to the power of n, and then at the very last step, it's going to multiply everything by t, which is not what we want. We need n and t to be done first. So we force them to be done first like that. All right, now it's good to go, except for the fact that we don't actually have values for r and n and t. Well, in this case, n means the amount of time, t is the amount of time, n is the number of times that interest is compounded per unit t. What does that mean? Well, compounded, 12 times a year, so that you get 12 months of interest. Then you would put t for 1 as a year, and n would be 12. So let's start filling in some variables. Let's say that we earn an interest rate of 0.10%. Pretty good yield. Let's say that t is equal to 1, that's 1 year. And let's say that n is equal to 12, 12 times a year. I'm going to make sure that I'm doing that right just by Googling up yearly interest formula. Okay, I'm going to go with it and assume that I got it right. Somebody tell me. Somebody's got to be a banking major. If you're doing interest, do you calculate it 12 times a year or just 1 time a year?
It depends on the compounding. It's like it depends on what type of interest you have, basically. So the most common is probably going to be annually, so it would be like once a year.
All right, so let's do that. So this is once a year. In that case, 1 times a year is kind of silly. There we go, 1 time a year. And by the way, your homework is going to be based on this. Doesn't mean you have to type it in right now, but it's well worth understanding. And then lastly, we're going to want to say print end amount is %.2f, maybe even a $sign in front of it to make it look awesome. End quote, %sign. And by the way, it's real hard for me not to type a comma there, right? Because we always type in a comma when we're separating print statements. But when you're using placeholders, you got to use the % instead. It's just part of the syntax.
Weird syntax, but it's part of syntax.
There we go. Right? So this should tell us what interest we earn. And in my mind, well, we haven't started off with A. A is your starting point. I'm going to make that a lowercase letter since the rest of them are lowercase letters. So A is, I started off with $1,000. If I get 10% interest, I'm kind of thinking in my, thinking, which could be wrong, that it's going to be $1,100 when we're done. Or not. Why is %P not? Okay, because I put a capital P there, and I made a silly mistake. Can somebody tell me why it's not working? I have my formula there, but
I don't know what that is. It's a comment.
Yeah, it's just a comment. There we go. Now it's actually going to work. And there we go. And that's pretty weird. That's not what I was expecting at all, because if you start with $1,000, you should not end with 905.
Did you put that's slash? That's division.
Yeah, so did I botch that in? It's not division, it's multiplication. Okay then. You would think that since I've done this example for like 10 years in a row, I would have gotten it right. Let's put a asterisk right there. A asterisk. There we go. Thank you. Thank you. You saved me some agony. Alrighty. Well, it came out to 1104.71. I was kind of expecting it to just be 1100. I don't know what I did wrong. It's close enough just for this homework. If you want to be totally awesome and you want to try to Google up the formula a little bit more and get it so that prove either that that's accurate or show me the accurate way, that'd be totally cool. What happens if it was compounded 12 times a year? I'm going to change that into 12, just to see the difference. Oh, that's what I did wrong. I changed my comment and I didn't change the value. Yeah, here we go. There we go. Awesome. It's behaving correctly now. So what is your homework going to be? Well, it's going to involve the interest formula. But if I tell you the rest of the homework right now, then people would actually start doing it rather than pay attention to the notes. So we're going to just leave the rest of this off. So to format data of type float, the field width followed by a dot followed by the precision. They show that you can use 0 as a field width to indicate that there's no limit. I'd prefer just to leave it off. So I'd make a %.2f rather than %0.2f. Either way works. So selection statements, if and if else. Now that kind of logic is easy to understand because it's one thing or another. If you've taken fundamental, you absolutely have these burned into your brain. Right, so if the temperature, if outside is 72 degrees, yeah, right. And then if the temperature is below 32 : print freezing.
Or burr.
Backspace, yeah, or burr. Else, print not freezing.
Or, I'm not going to say hot.
Yeah, hot, yeah. We'll change it in a minute to have a three-way example because there is no else space if in this language. And if you've ever done another programming language, you'll see else space if, and this one just uses elif.
Really stupid.
All right, so what if we wanted to say freezing, liquid, or boiling, right? Well, boiling is an upper range of 212. So I'm going to rewrite this if statement to make it say if temp less than 32, print parentheses, quote, ice, end quote, in parentheses, back tab, elif, temp less than 212, print parentheses, liquid. Now this is for water, because other liquids have different freezing points. Salt water has a lower freezing point, which is why you put salt on your ice. Else, print parentheses, steam, end quote, in parentheses. So since our water is 72 degrees, it's going to be liquid. But if I changed it to 272 degrees, it would be steam. Or if I changed it to minus 72 degrees, it would be ice. All right, so it's a liquid. I'm going to change it so that it's 720 degrees. It's a hot summer day. There we go. Right, so it's steam.
Or just like, ah.
Yeah, plasma. All righty, and then minus 720. There we go. Now it's ice because it was below 0, below 32 degrees. It'd be more cool for our example to ask for the temperature, but since we keep running this over and over and over, I don't want us to have to type in a value every time. But I'm going to show how we would ask for it, right? Temp equals float parentheses, input parentheses, 2 close parentheses, and then I'm going to put the double quotes right inside here. And inside the pair of double quotes there, I'm going to put the message. What is the temp of the water, question mark, space, space, something like that. or you know that I love putting that greater than sign there to show people where to type. So maybe the very last step I'll do is to go back in and uncomment that so it actually asks me for the temperature of the water. All right, same business.
Yeah. My program crashes.
Let me come look.
I made it real fun.
So if you're going to do some comparisons, I've already shown you doing equals. Equal. Why don't we zoom in on that so it's not microscopic. I've already shown you not equals, which is the exclamation mark, followed by an equal sign. And don't put a space there, by the way. That'll break the syntax. It wants those to be right next to each other. And just like in, grade school math or whenever you learned it, less than means less than, greater than means greater than. Greater than equal, or less than equal means less than or equal. Greater than. The only one that catches somebody sometimes is, it's been so long that I don't really remember, but I'm pretty sure that in school you probably learned that to mean not equals. Well, in programming they don't do that one, instead they use that.
They're like,
so a two-way selection statement is when you have an else. Because it does one thing or the other, that's why it's a two-way. They didn't format this correctly. There we go, right? So if the area is greater than 0, figure out the radius. Else, print. The area must be a positive number. And a double select statement, a two-way select statement, can be represented in a flow chart, which thankfully for y'all, I'm not going to ask y'all to draw, as if it's true, you do one thing. If it's false, you do something else. Or the simplest form, I don't even know why they show the two-way before the single way. You just leave off the else word. And so it either does one thing or nothing. Something or nothing. Simplest form of the selection is the if statement. If condition, then do a sequence of statements. Now that sequence of statements can just be one line or it can be 1,000 lines as long as they're all tabbed. So if the program needs to entail more than 2 courses of action, you use Elif. So for example, if your grades are above 89, you want to get an A. If your grades are between 79 and below 90, you want a B. If your grade's above 69 and below 80, you want a C. Otherwise, you get an F. This teacher's kind of harsh. She doesn't give D's. This would be a lot easier to read if we did this. And that should, of course, be a lowercase l. Thanks, PowerPoint. There we go. And there we go, right? So if your grade is above an 89, you make an A. Now, I would have made this greater than or equal to 90, right? Because this is telling me that if it's a 89.1, I made an A. Now, okay, personally, in this class, I kind of round up sometimes, but that's because they chose the word int there. Make it a whole number. I would make that a float, and then I would make that greater than or equal to 90, right? So if you made it greater than or equal to 90, it's an A. Now, a common thing for people to want to do is to encode both sides of the range, meaning, well, from 80 to 89. And so they want to write it, once they learn the OR statement, like this. Come on. They want to say if the number is less than 80 and the number is greater, right, or actually that's a 90, right. But you don't have to do that. You don't have to write it like this. You don't say L if the number is less than 90 and, because you already know it's less than 90 because of the first one. So we can leave that part off. L if the number is greater than 70, you're in a C. And if it's below a 70, the final else makes it an F. This is pretty much almost exactly like our ice, our steam ice liquid version, except we only had one Elif rather than two. So Elif is represented by like this. If something's true, do one thing. Elif something else is true, do something else. And if all of those were false, you do a third thing. Here's an example of using OR. Both conditions have to be true. Or no, one or the other has to be true. That's what OR means, right? Either or. Only one of them have to be true. If it's raining, or if it's cold, wear a hat. Nobody wears hats anymore. But you can imagine, right? You might want a hat to keep your face warm, or you might want to wear a hat because it's raining. So you can use that to check, like for bounds, to see if something is outside of a range. And that's what this showed right here, right? If the number was less than 0 or greater than 100, then somebody made an error. So we're going to do that to our temperature. And it's getting to the point where this example is so awesome that we should actually do that, but I'm not going to. So let's make sure that that value, we're going to reverse the logic of this so that we print not freezing first and then freezing as our else. But to do that, since we're checking outside of a range, we need OR. So if temp less than 32 or temp greater than 100, colon, print not liquid, right? Because if it's less than 32 or it's greater than 100, it's not liquid. So you use OR.
Danger.
Yeah. So you use OR to check to see if one condition or the other is true. If you're sick or tired, you get to stay home. How's about we use and? And means both sides have to be true. So if the temperature is greater than equal to 32 and the temperature is less than or equal to, why did I say 100? That's Celsius. It's 212. Colon, print liquid.
That's not going to work.
What'd I do wrong?
Well, should I say? It's going to do both. It has to do both.
It does have to be both, right? Because it's only a liquid when it's greater than 32 and less than 212. It's the only time it's a liquid. So you can use OR to check outside of a range. Add a comment to that effect. Use OR. Guess I'm going to put OR in quotes or else it looks funny. To check outside of a range. And use AND to check inside of a range. But not just for ranges, right? Any two conditions can be ORed or AND for whatever purpose you need, right? If weekend or holiday, sleep in. If sick and tired, stay home. Man, that's a mean boss who makes you come in unless you're both sick and tired.
It should be or.
Yeah, I'm going to change that to or, right? Although then, you get fired for every time you stay home just because you were tired, but whatever. if I have money, if money is greater than $10 and my hunger is greater than 10, go eat out, right? Otherwise I stay home. No reason to stay home if I'm not, no reason to go out if I'm not very hungry. No reason to go eat out if I can't afford it. So or means one side or the other has to be true. Either one side or the other must be true. And means both sides have to be true. One more thing, I'm going to talk about ands and ors. But I'm just going to put it in a notepad to indicate that you really don't have to type this in. What if we pretended that 0 means false and 1 means true? Old days, binary. So we're going to do an and truth table. X and Y and the result. So if neither side is true, then the result is false, right? If these are both false, then the result is false. But and requires both of them to be true. So if one side is false and one is true, the result is still false. If the first is true but the second is false, then the result is still false. The only time and is true is when both sides are true. How about or? X or Y and the result. Well, if neither one is true, it's still false. But if one of them is true, then the result is true. If the other one is true, then the result is true. Or if both of them are true, then the result is true. Now if you look at this, this just about looks like multiplication. 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. And this about looks like addition. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1, well, we'd think it was 2, but in this logic, all you have is true and false. You don't have a third state. So 1 plus 1 is 1. So and is logical multiplication. And if you ever take a logic course, then you'll probably represent and with something that means multiplication. And or is logical addition. All right, so your homework for today is going to be pretty easy if you know how to do the input statements we've been doing. Some folk have had to ask me for help on doing the input, which is why I show input being gathered here, right? You can also do it long form, where you do a print and then you do an input statement and then you do a conversion. Both of those work. Both of those work just fine. Print what is X, question mark, space greater than, end quote, and then get X. X equals input, parentheses, in parentheses. Oh, I don't need to put the greater than there in that case. I'm going to put it inside here. And then convert it to a float. That's one way of doing it. Or you make it just in one line if you think it saves you some typing. X equals float, parentheses, int, parentheses.
Wait, what?
Yeah, that's good. Float, parentheses, input, parentheses, what is Y, question mark, space greater than, end quote, in parentheses, in parentheses. So there we go. Which way you want to do it is up to you. MindTap in their examples shows you that way. So I'm going to run it, prove that they both work without syntax error. What is X? 10. What is Y? 20. And if I look up, the only difference in the way they work is that if you combine the float and the input and the print statement all into one, then you put your answer on the same line of text. But if you do a print followed by an input, then you type in below. Whichever you like. I kind of like that better. All right, so what's your homework? We have this formula up here. Just ask for the starting amount, the interest, expressed as a decimal. If you type in 10, it's going to mean 1,000% interest. That would be pretty cool to earn. And then the number of times per year. No, that's not wrong. It's the number of years. And this is the number of times per year. Just write a program that asks for all four things and print the result. So I'm going to just copy and paste that down at the bottom as part of a homework statement. Homework. Here is code that calculates interest. Modify it to ask for A, R, T, and N. And be descriptive. Don't just say what is A. Say what is the starting amount.
That's 12:15.
Well, that's not all the code that does it. That was just this. I didn't print out the form, so when I copied and pasted, I failed a little bit. Let me go and grab the print statement. If you were only interested in the amount of interest, well, that sounds weird. If the only thing you needed to know was the amount of interest, you could subtract the end amount from the starting amount. If you feel like making it add that, right, interest earned is equal to P minus A, you could do that. Okay, so that's the homework. And you absolutely do not need to type that in. I always upload the instructions to the homework if I've done a good job. Are there any questions? Anybody want a printout? I'm going to make at least one printout because usually... All right, let me make 2 printouts. All right, gang. Make a Dropbox and we'll be out of here.